All right, so today we're going to be talking a little bit about some of the more important reactions involving carbonyl compounds, specifically aldehydes and ketones. Okay, there are a couple of things that we should, fundamentals that we should go through before we actually start talking about specific reactions. One of the things about the carbonyl group is that it's extremely polar, all right? And the reason for that is because you got this carbon, which has a relatively low electronegativity, hooked up to an oxygen, which of course is very high in electronegativity. All right, so as a result of this electrophilic character of the carbonyl carbon, it's sort of like a natural attractant to nucleophiles. All right, so probably a more descriptive way of depicting the carbonyl group is like this, where we actually show these partial positive charges on the carbon and a partial negative charge on the oxygen. All right, and it's this that makes it reactive. Okay, it's the fact that we've got a fairly strong electrophile in this carbonyl carbon. All right, so that's one thing that'll affect the reactivity of these things. In other words, if there are ways we can increase the electronegativity of this carbonyl carbon, it's going to make the carbonyl compound a lot more reactive. All right, now there's another factor too that has to be taken into consideration, and that's the steric bulk of these groups that are flanking the carbonyl carbon. All right, so like if we have a couple of tertiary butyl groups here, this thing is not going to be reactive at all because the nucleophile won't be able to get in close to the, close enough to make a bond. So let's take a slightly more detailed look at these factors. Okay, so with the electronic effects, if we have CH3s or any kind of alkyl groups, they're going to be more electron donating, right? You all know that from when we talked about carbocations, we saw that the more highly substituted the carbocation is, the more stable it is. And the same thing happens with these carbonyl carbons, right? If you've got big alkyl groups attached to this, what's going to happen is that they're going to donate electron density down into it, and as a result, the carbonyl carbon will become less electrophilic, less reactive. Okay, so here are a couple of typical examples. So probably the most reactive of these carbonyl compounds, these aldehydes and ketones, is this compound here. This is formaldehyde. And you notice that we don't have any kind of electron donating group attached here. The only thing we've got is we've got two hydrogens, which aren't really effective at donating electron density. So formaldehyde is actually quite reactive, right? In general, aldehydes are going to be more reactive than ketones because obviously you don't have quite the steric bulk. And the other thing is that you have one less alkyl group donating electron density. Okay. Now, the other thing that we can do in order to make these carbonyl compounds more reactive is we could stick electron withdrawing groups on these alpha carbons. The alpha carbons are the ones that are directly attached to the carbonyl carbon. All right, so if we have a chlorine, for example, here, what it's going to do is it's going to tap off even more electron density from this carbonyl carbon. It's going to become more electrophilic, and it will be more reactive. Okay, so those are some of the those are some of the electronic effects that we have. With the steric effects, obviously, I mean, this is pretty straightforward. If we have big bulky groups, it's going to be harder for the nucleophile to come in and make contact with the carbonyl carbon to make the new bond. Okay, so like for example, here's acetone. You've only got two methyl groups. This is going to be more reactive than, say, what's this compound here? This is 2-butanone. All right. Because here you've got a larger alkyl group. You've got an ethyl group rather than a methyl group, and then finally a monster like this is going to be virtually unreactive, right? Because I mean, this is really going to be very crowded, and as a result, the nucleophile is going to have a tough time making its way into the carbonyl. Okay. We can also see with aldehydes are going to become a lot less reactive with, aldehydes are going to be more reactive than ketones from the steric point of view as well, because as we said up here, you've only got one alkyl group blocking the access to the carbonyl, whereas with a ketone, you've got two. Okay?